In this video, I'd like to talk more about explicit formulas for arithmetic sequences. And remember, the explicit formula essentially will tell us what a specific term is in the arithmetic sequence. So when you see a of 1 for this formula, that just tells us we're looking for the first term, which is 81. And the general formula for these, I'll use a of n here, to find the nth term in an arithmetic sequence. Basically, you're going to start with the first term, which we call a of 1, and then we're going to add the common difference a bunch of times, or namely n minus 1 times. So this will be plus d, where d is our common difference, multiplied by n minus 1. So like I said, d, that's our common difference. So I encourage you to think about this to hopefully make sense of it. For instance, to find the third term, we're going to start with our first term and then add the common difference twice, since it's always one less time than whatever term we're looking for. So to find the fourth term, you add the common difference 3 times. And in this case, it looks like our common difference, which we call d here, we are subtracting the same number every time. Namely, we're subtracting 27. You can see that most clearly going from 27 to 0. So our common difference is negative 27, or subtract 27. So to find the fourth term, you start at 81 and then subtract 27 3 times. So that's why you're adding the common difference n minus 1 times. It's always one less than whatever term you're looking for, but your sequence has to start at whatever the starting value is, in our case 81. So our formula here, since we already found the common difference, and we know our first term is 81, we can write everything down. So the nth term in our sequence is 81. Start with your first term, and then add your common difference n minus 1 times. Well, in this case, we're actually subtracting a common difference, and that common difference is subtracting 27. And again, we're going to do that n minus 1 times. So once you think you have a formula here, it's a good idea to check these, just to make sure that you're doing this correctly. So let's check over here, and we know that our fourth term is 0, since that was given to us. But let's check that in our formula. So a of 4 would be 81 minus 27 times 4 minus 1, which is 3. So if we multiply minus 27 times 3, that would be minus 81, and that is 0. So our check worked, and so that helps us feel confident that this formula is indeed correct. So for all these problems, you basically just want to remember this general formula. But you should also make sense of it, because it does make perfect sense that this is the formula. You start with your first term, and then you add the common difference n minus 1 times to be able to find that nth term. So you're adding that common difference one less time than whatever term you're finding, since you're not adding the common difference to the first term. So with this in mind, let's look at another example just like this, and then we'll look at 2 more challenging examples. So for this one, we have minus 5, 13, 31, and so on. And to write out our formula, so we have b of n in this case, it's our first term, which is negative 5, and then we're going to add that common difference n minus 1 times. But we need to be able to figure out what d is in this case. So we know d, that's what we call our common difference, and we basically just need to figure out what are we adding from one term to the next. And to go from minus 5 to 13, it looks like we add 18. Well, let's check that. If we take 13 and we add 18, it looks like we do get 31. And adding 18 again, we do get 49. So in this case, our common difference is 18. So let's plug that into our formula. So b of n is our first number, minus 5, plus that common difference of 18, and we'll multiply that n minus 1 times. So let's check our work here, just to make sure. We want to be certain that this formula is right. So let's find this fourth term again, and you can find whatever term you want besides the first one. But we want to find b of 4 since we know that should be 49. And plugging that into our formula here, so b of 4, we would get minus 5 plus 18, and we want to add 18 3 times, since 4 minus 1 is 3. And 18 times 3 would be 30 plus 24, that's 54. And minus 5 plus 54, that is 49, which is what we expected. So that helps us feel confident that this formula is indeed correct. And when you're first learning this, it might not be a bad idea to check multiple different terms just to make sure the formula works for all of those. Or you could start with your formula and then try to regenerate the sequence one term at a time. And the more you practice, the less you have to check. But even if you've been doing this for 20 or 30 years, you're still going to make mistakes. So this extra step of checking, which does not take that much longer, should be a part of your work for all of these, just so that you can be certain that you're right.